Okay, can you hear me? Yes. Okay, thank you. Okay, so we will start today's session. So basically today is our third number of class, and after completing the live training, then we talk about that problem solving for the previous class. Okay, so let me share my screen. Okay, now can you see my screen? Is it visible? Thank you. So basically today's session I try to discuss about that this type of topic, mainly calculating any indices from satellite images using Landsat and Sentinel imagery, how we can easily use, and then make the different calculate the different types of indices. As well as we also discuss about that how we can easily filtering and displaying the sentinel-2 satellite imagery and monitor the normalized difference water index and also normalized difference vegetation index. As well as also try to discuss about that thresholding, how we can easily apply the thresholding technique and extract the water body or any other specific pixel value, how we can easily extract using the thresholding technique, also discuss about that. And we talk about that different types of indexes time series chart using Landsat or Sentinel, and also talk about that how to export any shape file from Google Earth Engine and how to add the gradient legend and title on Google Earth Engine. As well as we also discuss about the flood mapping, how we can easily detect the flood water using the sentinel-1 SAR data. As well as we will discuss about the monthly time series chart, how we can easily work for the monthly time series chart and create the time series chart for NDWI, NDWI or any other indices using different types of satellite images, Landsat or Sentinel. Okay, so let's go try to start one by one. So first of all, I try to discuss about that how we can easily filtering and displaying the sentinel-2 satellite imagery, and further using this satellite imagery, how we can easily find out that water body. Basically we try to find out the water logging for the different season, what the situation of the water logging for any specific cities. We try to show this problem. Okay, so let's go. So just I simply increase my screen. Just I click on the browse data catalog. And from here we can easily get all of data set. So now I want to work for the Sentinel. So how we can easily filtering the sentinel-2 satellite imagery, and further using the sentinel-2 satellite imagery, how we can easily make the different types of index, and then further we try to apply the thresholding technique. Okay, so just you can see about the sentinel-2 multi-spectral instrument. So here we can get surface reflectance as well as what about the top of atmosphere. So both of image is the same for filtering. So I want to work for that, suppose top of atmosphere. Just click on here. Okay, so here you can get all of information about the Sentinel-2 multi-spectral instrument level 1 C data. So now this data set I want to use, and further I want to make the water logging map. So basically for the rainy season, what the situation of water logging, we try to find out that. So this data set I simply copy from here. This is the Earth Engine snippet. We already know about that. Basically Earth Engine snippet is the unique ID for any image collection. So this unique ID I simply copy and then paste in my code editor. then you can put any variable name, and we already know about that how we can set the variable name. Before the variable name, just put the var keyword. Okay, then put the variable name. Suppose I put the name is that sentinel-2. Okay, or you can put any name. So now this is my image collection. This image collection I store it in a variable. You can put any name as a variable. So now this image collection I want to filter. Okay, how I can filter? We already know about that. For filtering, mainly three factors. First factor is that where you need this image. Second factor, how image you need, suppose less than 1% or 2% or 5%. And third factor is that when you need this image. So where, how, when we are just use, and then we filter our image collection for a specific boundary, for a specific cloud cover level, and for a specific time period. Where, how, and when we are just apply, and then we filtering this image collection. So for that, where I need this image, so now I set my specific boundary. Suppose I need the image for a specific boundary of Dhaka city. So just I imported the Dhaka city boundary from my asset tab. So here I already import my Dhaka city boundary shapefile. Just I simply click on here. So now this shapefile is imported, and the default variable name is the table. So you can put any name as a variable name. I put the name suppose as a ROI, or you can put any name. Okay, so it's totally depend on you. So now I just simply import my region of interest as well as also import the image collection. So now I apply where, how, and when, and filter this image collection. And this image collection is already stored in a variable. This variable name is the sentinel-2. Okay, so let's go try to filter, and now I need the image for the 2 season. Suppose I need the image for the dry season, another image I need for that rainy season. So for that I just write the code for suppose for the dry image or dry season image. So just take a variable. I put the variable name, suppose any name you can put as a variable. Suppose dry season image or dry image. So just I call my collection sentinel-2. Basically this collection is stored in this variable. So just I simply copy this variable name and paste here. And further I filter. First condition or first factor is where. Where you need this image? I need the image for the Dhaka city. For the where we use here a function. This function called the filter bounds function. So filter bounds function mainly intersecting with your region of interest. So in this time here you can see about that argument is the geometry, same as I just put my shapefile variable name. So now shapefile variable name is the Dhaka city. Just I put here that ROI. Okay. After that I want to filter the how I need this image. Suppose I need the image less than 1% cloud cover. So just I put here that filter metadata and put here these 3 property. One is the name, operator, and value. So name mainly your image properties name. So here you can see about that image properties name. You can get all of image properties from here. So I want to work for that, suppose cloud pixel percentage. I simply copy these properties, and then further I just write in the name, just put the quotation because it's a string group of character. So that's why you must use at the before and start must use the quotation. Then operator, I set the operator less than and set the value for 1. Okay, so now I filtered this image for using the image metadata. So I choose only for this image which image will be not more than 1% cloud pixel. Then when you need this image, I need this image for suppose in a dry season. Okay, so further use the filter date function. So now I put a specific time period, suppose for dry season based on Bangladesh. I put this suppose 2020 1st January from 2020 suppose April 30. Okay, so I choose this time period as a dry season time period for Bangladesh region. So now further you check here, suppose I simply put here the print function, and then I simply call the dry image and paste here, and also use the size function. So now it's computing after filtering how much image collection is stored in this variable. So we find out that this variable is stored total 20 images. So now further I want to make the median composite and try to use it. So just I put here that dot median, and then further use the clip function, clip with my study area, which is ROI. So now display these images. So just I simply comment this line, and then I just show the image map.add layer and call my object name. I want to display the dry season image, and it is stored in a variable. This variable name is the dry image. So simply copy and paste here. So now you can see it will be loaded a layer, but it not focus the center of this boundary. So we already know a function. This function called that map.center object. My object name is that ROI. I put the ROI and put here the suppose 10. So now click the run. So now it center focus on my given boundary. So we can get this type of black color imagery, look like that. So now I just simply set here, suppose click on here, and now we easily set the band combination from here. Here you can see one problem. This scale is not reprojected. It show about that very long value, large value we can get it. So for scaling this type of band pixel value, they already provide some scale. Here you can see they already provide the scale value, and all of band have the same scale value. You can see 0.001. So this scale value I simply copy, and after median just I multiply. So just put here that multiply function and then use it. So now we can get that proper pixel value for each band, and we can easily get the more better pixel. So just click on here. So now you can see you can get the 6.5. So it's the spectrum value. So just I simply put here suppose red, then put here that green, and put here the blue, and further stressing, and then just apply. So now we can get that natural color band combination. So we can get this type of band combination. So here you can see, and it's the sentinel-2 satellite imagery. So this is the 10-meter resolution. So that's why it's more better than Landsat imagery. If you want to use it for your land use land cover or NDWI or any other remote sensing analysis, you can get that more better result than Landsat imagery. But this image collection is not for past time. We did not get it. We can get the sentinel-2 image collection from year of 2015. Okay, 2015 we can get it. Okay, for present time 2024. But when you want to work for that historical data analysis, then you must use here the Landsat imagery, because Landsat is available from 1973. We can easily get it all of images from 1973. But Landsat is 30 meter and sentinel-2 is the 10 meter resolution. So that's why when you want to use for that sentinel-2, we can get the more better result, more better accuracy for land use land cover or NDWI or any other remote sensing analysis, because this pixel size only for the 10 meter. Okay, so here you can see you can get this type of image. So this is the one way. This process we already know for filtering. So now I will show you the another way for filtering. Okay, so in another way is that instead of the filter metadata function, we can also use the other function. It's called that short function. Okay, short is another function. This function is also used to filtering image metadata. So now I want to use the short function, and I will show you that how it will work. So just I simply commenting the filter metadata, and I want to short using the cloud pixel percentage. This properties I want to use in here, and then paste here. Okay, so between this time period, so all of it is the same. So now you can see what happened. I simply click to the run. It also loaded the images. There is no problem. But we find out that lot of cloud in my images when I use the short. So now I'll show you the visualization. Just I click on here. And then I put here suppose B4, B3, and B2. And just stressing 98%. And further just apply. Okay, so we are after the short function, we have to use that. Okay, sorry, we have to use the another way. So I want to not use the median. I want to put here the mosaic. Okay, mosaic. And what is the difference between the median and mosaic? So basically when you use the median, it just take the middle pixel value and create this composite. And when I use the mosaic, it don't take the middle pixel value, it make the composite using all of images together. So now here you can see, I will show you this result first. Suppose B4, red, green, and blue. And also apply. So now here you can see it show about that lot of cloud and there is no image in here. Okay, when I use the mosaic. So basically when I use the mosaic, what happened? It collect all of images and create the composite using marks. So that's how you can get this type of things. But when you use the sort function and apply the false boolean operator, just put here that false, this is another boolean operator. When I set the false, then all of those cloud, the image will be removed and we can get that more better image. So now try to check it again. So just I run the code after adding the false boolean operator. And then I set the pen combination, suppose red, green, and also blue, and further stressing 98%. And apply. So now we can get that more better image, you can see here. But in this time, this image, this composite, it created using by mosaic. Okay, it don't take any kind of middle pixel value, it don't take, because when you use the median, then all of images middle pixel value take and create this median composite. But in this time I use here the mosaic. So mosaic mainly all of images create this composite without taking any kind of mean or median pixel. Okay, it creates this type of composite. So you can see you can get this type of imagery. So in this time we learn about the new function, sort function. Okay, so it also use. So in this time, sort function and filter metadata function, this two function is used for filtering the image metadata. But you can see here, when you apply a range, suppose you need the less than 1%, less than 2%, less than 3%, or less than 10% imagery. When you want to filter, then use the filter metadata function. Okay, but in this time, for the sort function, we are not apply any kind of specific range. So we take all of cloud pixel percentage, or we take all of cloud p imagery and then apply the false function. This false function mainly remove all of cloudy pixel automatically in Google Earth Engine. And then we can get the very neat and clean imagery. Okay, and when I use the mosaic, then all of image create this composite using the marks. And further we multiply with that 0.01 and click with our shapefile. So this is the another way to applying the sort function instead of the filter metadata function. Okay, and also mosaic function, it also used instead of the median function, we can also use it. So this is the another way for filtering in Google Earth Engine. So now after I just import this visualization, a new line of code will be added in my code editor. I just simply copy and further paste after the object name. So this is my object. I set the visualization and then further I just add here a layer name. You can put any name as a layer. Suppose I put the name is that suppose natural color, or you can put any name. So now this is the set for our one time period image. Sorry. So now we try to find out the another time period imagery. Suppose I need the imagery for rainy season image or rainy image. I just put in here. So just here use the same. All of things will be same. Just I copy change the date. So I simply copy the same code because I use it again. So same and paste here. So just I simply put the change the variable name. Suppose I put the variable name is that wet image or rainy season image. So you can put any name as a variable. And then I simply change it. Suppose I put the time period for May to October 30. Okay, and then all same, just simply copy and then change the object name. Okay, I will later add the visualization. And then natural color, I put here that it's a rainy season image or rainy image. So now click the run. So now it added the two layer, one layer for that dry season, another is the rainy season. You can get this type of black color because we don't add the any kind of visualization. So now set the visualization from here. Just click on here, and I set suppose before red, then green, and also blue. So stressing 98%, and further just click on the apply. So now we can got this another imagery. So just I import this visualization and further copy this variable name and then paste after the object name. Just a paste here. Okay. So now here you can see you can get the two time period imagery. One is the rainy season, another is that dry season. So in the rainy season and dry season, you can see what the difference between the two images. Dry season image is very neat and clean. There is no cloud. It's very neat and clean. But rainy season imagery, we find out that some haze, as well as we also get some cloudy pixel, white color cloudy pixel. So basically this is the cloudy pixel. Okay. This type of cloud we also remove. For next class we try to discuss about that, how we can remove the cloud. So basically cloud is hampered for the land use land cover mapping. So that's why it's very important before making the land use land cover mapping for rainy season, you must remove the all of cloud, otherwise you don't get the more better result. So it's very important for removing the cloud when you want to work for the land use land cover classification map. So here you can see we can get this type of cloudy pixel. So next class I try to show you that how we can remove this type of cloud and get the very neat and clean imagery. So now this both of imagery